What's it for?
It's Moho Day.
What's a moho?
The moho is the discontinuity in the Earth between the crust and the mantle.
What?
You don't know the structure of the Earth?
Apparently not.
Well, let's go to the kitchen and we'll show you.
Okay.
This is a cross-section of what the Earth would look like if you were to cut it in half. The crust, ding! The mantle, ding! The core, ding!
Oh no, I still can't see the moho.
Well, let's look at something with a larger scale. Size matters. We'll zoom in.
Okay.
You can divide the Earth in two different ways, chemically and mechanically. This cake shows the chemical boundaries of the Earth, which are defined by compositional variations within the planet. These are divided into the crust,
Ding!
mantle,
Ding!
and core.
Ding!
The average depth of the continental crust is 35 to 40 kilometers.
But I still don't see the moho.
The discontinuity between the crust and the mantle, which is compositional, is called the moho.
Oh.
The mantle is the solid shell of the Earth extending from the crust to the core, or from the moho to around 3,000 kilometers, where you reach the core mantle boundary. At the center of the Earth lies the core, composed of iron and nickel. This cake shows the mechanical boundaries of the Earth, which are defined not by chemical variations, but by physical properties. These boundaries are the lithosphere
Ding, ding, ding!
and the asthenosphere. The lithosphere consists of the rigid or brittle outer skin of the Earth, which includes the crust and uppermost mantle. The asthenosphere is the region of the mantle beneath the lithosphere, where behavior is more plastic, emphasized by the more pliable frosting as compared to the more brittle cake-like lithosphere. Heat is transferred by conduction in the lithosphere and convection in the asthenosphere. The two regions are divided by the lithosphere-asthenosphere boundary, or LAB, which is approximated at a depth of around 200 kilometers by P and S wave velocity profiles. Now, let's look at them side by side. Here is a side-by-side comparison of what we've already seen.
So this is the moho, and it's a chemical boundary, and this is the lab, and it's a physical boundary.
Hey, now you're getting it.
It's not that hard.
Hey, don't eat the crust!
Why? You haven't said anything about it. I didn't think it was that important.
Yes, the crust is very important. Let's take a look at the crust, shall we?
Okay.
The continental crust is formed by accretion and has an average thickness of 40 kilometers. It has a granitic composition. Continental crust cannot be destroyed. The oldest known crust is 4 billion years old. But don't take it for granted because humans need it to live on.
I guess that makes it important. But is that all there is?
No, let's look at the oceanic crust.
Okay.
The oceanic crust is formed by seafloor spreading and has an average thickness of 6 kilometers. Oceanic crust is basaltic in composition, like this piece of basalt here.
Ding!
The oceanic crust is destroyed at subduction zones, and the oldest known is 170 million years old. To fully understand the thickness differences, let's look at these two crusts side by side.
Okay, so I can totally see the thickness and compositional differences between the two, but is that it?
No, actually, there's a density difference between the crusts as well. Continental crust is on average 2.7 grams per cubic centimeter, whereas oceanic crust is 3 grams per cubic centimeter. So, oceanic crust is slightly more dense than your average continental crust.
And that's why the continental crust can float, right?
Yeah.
Okay, and the moho here is still just a chemical boundary, even though it's at different depths?
Yeah, because it marks the boundary between the crust and the mantle.
I think I get it now. Happy moho!